In this video, I'll be doing a detailed solution to the question you see on the screen here from 2024 Cambridge A-Level Maths Exams Paper 2-1. If you're looking for a different question from this paper, have a look in the playlist in the description below. Or if you're looking for a different paper entirely, search around on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we're not in a classroom, we're on YouTube, so take advantage of that, use the pause button, even change the speed at which you view it. If you do find this video useful or any of the videos on my channel, I do greatly appreciate a like, a subscribe, a share, or even a super thanks. Part A of question 3 gives us these two equations and asks us to sketch them. So we don't have to be perfect when drawing them, just need to sketch them, need to get the important points across. Okay, this one, first of all, very easy to do. Let's make a big graph here. If we rewrite this as y is equal to minus x plus 5. Sorry, I should say there's two ways usually to do these things. For a line, you just need two points. So I would often just put x equals 0 and get the point y is equal 5. So that's, what do I need for this? So let's say 5 is about here. And the other way, put y equals 0 and solve for it, and you'll get x equals 5 down here. That's one way. The reason I rewrote it like this, the way I usually think of it is I write like this and I get this number as my y-intercept, which is this point, and I use the slope. And the slope is -1, which means it'll come down at about 45 degrees. And if there's a 5 here, there's a 5 here. Either way, yeah, that's a sketch of this drawing. That's what they're looking for. Now, the sketch of this one is a bit more complex because it's a absolute value. How I draw these is I just ignore the absolute value. So 3x minus 8. And I don't draw this line yet. I just put a dotted line in for this. So this is, the y-intercept is -8. So we go down to about, say, here as -8, and the slope is 3. So that means every one I come over, I go up 3. So this is -8. So I'm up to -5. Another one, I'm up to -2, and I have 2 left. So that hits at 8 over 3. 8 over 3 is just less than 3. Let's say somewhere like here. So put in a dotted line for this guy. This point here is 8 divided by 3. You could also just get that by put this 0 and solve for this. X is equal to 8 divided by 3. So this is just a dotted line because the absolute value, so this is not the same as this. The absolute value tells us if it's a positive, leave it alone. Everything above this line is positive. And then it tells us if it's negative, change the sign. So if it's a -8, it becomes a +8. If it's a -1, it becomes a +1. -2, +2, and so on. So we'll end up getting this bouncing effect. We'll get this V. It's a mirror image of it there. And this will be our sketch. Just put in a few numbers. Like I'd want to see the 8 here. I'd want to see the x-intercept. This is for the absolute value. I want to see where it bounces. I want to see this 8 number here, and I probably want to see a dotted line down to this -8 number, but they'll forgive if that's not there, I would imagine. Okay, so that's the answer to part A. In part B, they tell us to use this idea to solve the inequality of these two. Yeah, let's write it out again. 3x minus 8 is less than 5 minus x. So if I'm given this inequality, this is how I solve it anyway. I like to draw a picture and solve it using that. You can solve this by squaring sides if you're careful, or accepting that there's 2 possibilities here. That's probably the easiest way to do it. But from the drawing, what this means is this side's the V-shaped, this V shape here. When is that less than this? So the two important points, let's zoom in on this area if you don't mind me doing that. You zoom in here, we get something like this. So the important idea is when is this phi less than this line? So that's anywhere past here. and anywhere before here. So if I just jot this down, somewhere there's some point here on the x-axis. Some point here and here. Let's call them A and B. A and B here. And the answer is simply, this is true when x is bigger than A and less than B. So really, I just need to find A and B. Forget about the absolute value. I just need to find when these points intercept. So instead of the absolute value, what I would do is I'd find B first. We know this line. This line is y is equal 3x minus 8. And we know this line. That's y is equal 5 minus x. Just solve that. Just solve for that. In fact, let's write that as minus x plus 5. Just solve that. Take them away. This one minus this becomes 4x. This minus this, minus 13 is 0. X is equal 13 over 4. That's this point here. That's this point here. X is less than 13 over 4. To get the other one is a little bit more complicated, because we don't have an equation for this line. This was the bounce of this one. But hopefully it's quite easy to see. The y-intercept is 8. And the slope of this one was 3. The slope of this one is minus 3. Or a much better way to think of that is, it's just minus this. Minus 3x minus minus 8 plus 8. So when does that intercept this other line? Y is equal minus x plus 5. Again, take them away. Minus 3 minus minus 1 is minus 2x. 8 minus 5 is a 3. That equals 0. That gets us 2x is equal 3. X is equal to 3 over 2. And that would go in here, 3 over 2. That'd be the full answer to this question. When is this less than that? It's when it's bigger than this and less than that. And the advantage of drawing is you don't have to worry about getting these signs correct. That's the mistakes most students make when they square both sides or when they change signs. The inequality gets messed around. Doing it this visual way lets you just say, ah, look, I see, it's less than here. It's between these two numbers. Sometimes you would, if they had said bigger than, we would know, it's everywhere over here and everywhere over here next to these two numbers. Okay, hopefully that helped. For part C, let me clear off the board so we have a bit of room. In part C, they give us this complicated looking inequality, but hopefully you notice this is very similar to this one up here. This one is just 3 times something minus 8 is less than 5 minus something. Well, that's what we have here, 3 times something, same something down here. So the answer, which I've rubbed off, the answer we got to the first part, let's put it here, x is less than 13 over 4 and greater than 3 over 2. Also holds true for this, this e to the n. E to the 0.1 n is also less than 13 over 4 and greater than 3 over 2. Sorry, the question asks, what's the largest number for n that makes this work, this equation here work? And that will just be, what's the largest n can get? It's just solving this right side here. Now that might not be clear because it would depend on the equation. So just be warned, you might want to have a look at this side as well. This being bigger than 3 over 2. It doesn't matter in this case. And that should be clear if you know what e looks like. E to the power of something times x or n even looks like this. It's going up, especially when n is going up a positive integer, the largest positive integer. This goes up, this goes up. So this is the one we're care about. So basically that is to say I want to solve e to the power of 0.1 n is less than 13 over 4. So we just go ahead and try and solve that. Get rid of e, like we want the n on its own. Get rid of e, that's the natural log of both sides. That gives us 0.1n is less than the natural log of 13 over 4. We want to multiply both sides by 10. That's what 0.1 multiplied by 10 to get rid of that. N is equal 10 times natural log of 13 over 4. Just put that in a calculator. We get n is less than 11.79. So what's the biggest possible n? The biggest possible n would be 11, integer that is. What I meant there was sometimes if this function here was a negative, as it got bigger, maybe it got smaller, you might care more about this number. But once you're careful with the inequalities, it should be obvious at the end. N is less than this. Sometimes you might have got n is bigger than a number, and you realize, oh no, I should have used the fact that this is bigger than 3 over 2. It really didn't matter in this question. It's just something to keep an eye out in the future. Okay, that's it for question 3. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a good day.